Section 6.8, Graphing Radical Functions. By the end of today's lesson, students are going to be able to graph square and cube root functions. Let's start by looking at square root functions. The general form for a square root function is y equals a times the square root of x minus h plus k. From a long time ago, if a is greater than 1, it's going to make it a vertical stretch. If a is greater than 0 but less than 1, it's going to make it a vertical compression. And if a is negative, it's going to reflect over your x-axis. Okay, talking about h. If it's minus h, remember we always think of it as the opposite. It's going to move to the right. And if it's plus h, it's going to move to the left. It would help if I could spell the word right. Okay, at the end, the plus k is going to move it up. The minus k is going to move it down. Let's add to this and let's talk about the domain. So remember, the domain is the x values. So your domain is going to be a bracket from h to infinity. The range is your y values, and it is going to be from k to infinity unless a is negative, and if it's negative, it's going to be instead negative infinity to k. So this is the exception right here. The parent function of the square root graph is just y equals the square root of x. So we're going to make a t-chart to find out what it looks like, and I'm just going to pick some negative numbers and some positive numbers to plug into the equation for x. So if we try to take the square root of negative 1, your calculator should tell you an error, so that means that this is undefined. Okay, plug in the square root of 0. The square root of 0 is 0. Plug in the square root of 1 and you get 1. And then the square root of 4 and you get 2. So you are going to only graph the points 0, 0, 1, 1, 4, 2. And your graph kind of looks like this. Here's 0, 0, 1, 1, and then 4, 2. And your graph looks like this for square roots. We are then going to take those 3 points and shift them around. The domain for this problem, since there is no h value, is from 0 to infinity. The range for this value, again, since there's no k, is also from 0 to infinity. Now let's practice graphing it with the translation. So we have y equals 3 times the square root of x plus 2 minus 4. Okay, so 3 is your vertical stretch. The plus 2 is going to move your graph to the left 2, and the minus 4 is going to move your graph down 4. So vertical stretches, remember, take your y values and you multiply it by that. So 0, 0, 1, 1, 4, 2. So I take my y values and I multiply them by 3. So I get still 0, 0, 1, 3, and then 4, 6. So I'm going to start by graphing those points. So I graph 0, 0, 1, 3, and then 4, 6. So my graph looks like this. Now I need to move the points to the left 2 and then move them down 4. Left 1, 2, down 1, 2, 3, 4. Left 2, down 1, 2, 3, 4. And your final graph looks like this. Okay, let's talk about the domain. The furthest x value that we have is -2, so it's from -2 to infinity. The range value, the lowest range value that we have, is this bottom number, and that's -4, so it's going to be -4 to infinity. Now we're going to look at the cube root function. So the general form for the cube root is y equals, a times the cube root of x minus h, and then plus k. So the exact same thing as the square root, the only difference is that 2 on the outside. So the a is still a vertical stretch or a vertical compression or reflect. The h is either going to move it to the left or to the right, and the k is either going to move it up or it's going to move it down. Exact same thing as before. So let's look at what the parent function looks like. The parent function is y equals the cube root of x. So if you think about cube roots, you can plug in negative and positive numbers, and I'm just going to pick numbers that are perfect cubes. So -8 is a perfect cube, -1 is, 0 is, 1 is, and then 8 is again. So the cube root of -8 gives me -2, the cube root of -1 is -1, cube root of 0 is 0, cube root of 1 is 1, cube root of 8 is 2. And I'm going to draw you what this looks like. Alright, -8, -2, so over here, -1, -1, 0, 0, 1, 1, 8, 2. And your graph looks like this. Since there is arrows on either side of this, the domain is -infinity to positive infinity. Same thing for the range, nothing's going to keep it from growing, so it's -infinity to positive infinity. Our next example is y equals -2 times the cube root of x minus 1 plus 3. So that -2 is a vertical stretch, and it's going to make it reflect over your x-axis. The -1 is going to move your graph to the right 1, and the plus 3 at the end is going to move your graph up 3. So since I have a vertical stretch, I need to make my table of values. So start with your -8, -2, -1, -1, 0, 0, 1, 1, and lastly 8, 2. And I need to multiply them by what a is. So in this scenario, you're going to multiply by -2. Let me see if I can fit this in here. So -2 times -2 gives me +4. -1 times -2 gives me +2. 0 times 0 is 0. I'm just going to come over here, guys. 1 times -2 is -2. And then 2 times -2 gives me -4. So I'm going to go and plot those points now. So all what I did is graph these points down here. -8, 4, -1, 2, 0, 0, 1, -2, 8, -4. Now we have to move those points to the right 1, and then we have to move them up 3. So to the right 1, and then up 3. Right 1, up 1, 2, 3. Right 1, up 1, 2, 3. Right 1, up 1, 2, 3. And then I think I need to add some more at the top. 3. So then you go to the right 1, and you go up 1, 2, 3. And so your final graph is this pink one over here. Okay, again, the domain, negative infinity to positive infinity. The range, negative infinity to positive infinity. Now let's look at rewriting a radical function. So if you notice, underneath my radical, I have an 8 in front of my x. We have to get that 8 out of there because we need to make it the a that's out in front. So we factor out an 8, and that's going to leave us with x plus 4. Then we're going to take the cube root of 8, which is going to give me 2. It's now not under my radical, but I cannot take the cube root of x plus 4, so it's going to stay x plus 4. So now I have a vertical stretch by a factor of 2, and then I'm going to move it to the left 4.